Steel is everywhere. Steel is used for the construction of infrastructures like bridges, cranes and so on. But traditional steel making, which is based on blast furnace, is also contributing significantly to the emission of CO2. It is possible to decrease the CO2 emission for the production of steel by increasing the amount of scrap used in the processing. That means that then we will recycle material, but steel that was already produced in the past. The advantage of this method is that we do not need so much raw materials. The disadvantage is that we get more residual elements in the steel. Some of these elements are well known. You have elements like copper, nickel or molybdenum that are well documented, but some others are much well known, like arsenic, lead or tin. For this element, it's important that we determine if they lead to an increase or a decrease of the strength of the material and if they will embrittle the material. This is where the EU-funded project MOWSES comes in. So in this project, we investigate the influence of these different residual elements on the properties of steel, specifically for steel welded components. Using advanced numerical techniques, experimental techniques like welding and simulation tests, and artificial intelligence, we will determine the conditions such that steels produced with an increased amount of scrap is as reliable as the material that we use today. The project will focus particularly on the welds because they are the critical areas in a structure, as they are more prone to presence of defects compared to the base material. In the welds, a particularly point of attention will be the heat-affected zone, where the base material microstructure is completely transformed by the heat from the welding process. The welding process will be investigated in relevant industrial conditions for construction of infrastructures. In particular, we will look at gas metal arc welding and submerged arc welding. A detailed microstructure investigations will be performed in order to see what is the influence of the residual elements on the way how the atoms are arranged in the material. And then we want to look if these different organizations in the structure of the material is changing the material properties, so strength and toughness of the welds. At the end of the project, we'll produce welds in full thickness, so representative for the infrastructures like bridges or offshore wind turbines, and submit these welds to a complete program of mechanical characterizations. With this, we will demonstrate that it's possible to produce safe welded infrastructure using steel produced in a green way, so with increased amount of scraps.